I will have factorize 3m minus 6. Okay, then we'll have another question. X squared minus 8x plus 15 over 2x squared minus 7x minus 15. Now, and then we'll have another question. Bracket of 3n plus 1 all squared minus bracket of 3n minus 1 all squared is a multiple of 4 for all positive integer values of n. Okay, prove that this is a multiple of 4 for all positive integer values of n. Okay, now all this will bring us to a topic I called factorization. Okay, now what is factorization? Factorization is merely gathering like terms in a term, okay, or in a quadratic function rather, or a linear function, gathering up like terms and grouping it into a way that it will be easily accessible. For example, let's start with before we do factorization, let's do a little work on expansion, because it will help you really understand what factorization is about. Now, if you have x plus 2 into x plus 5, okay, now expanding it to be x into x plus 5 plus 2 into x plus 5. Okay, now this will give you x squared plus 5x plus 2x plus 10. Okay, now gathering like terms, you have x squared, this plus this is plus 7x plus 10. Now this is an expanded form of this. Now in factorization, they give you this quadratic function and ask you to factorize it and put it in this form. Okay, now let's start with the linear factorization first of all. Example of a linear factorization is this one that we're asked to factorize 3m minus 6. Okay, now in linear factorization, the highest degree is 1. Okay, as you can see, the highest degree of m here is 1, because m raised to power 1 is m. Okay, anything raised to power 1 is equal to that particular figure. Now 3m minus 6. Now for this one, we'll ask ourselves what's common between 3m and 6. You find out that it's going to be 3. So you have 3 into 3m divided by 3 is m, then 6 divided by, or minus 6 divided by 3 is minus 2. So you have m minus 2. Now this is a factorized form of this one. Now the second question we're asked was, now remember we're asked another question of x squared minus 8x plus 15 divided by 2x squared minus 7x minus 15. Now this is also a good example of factorization, because for the numerator we're going to factorize it, and then the denominator will factorize it too. Okay, now let's factorize x squared minus 8x plus 15 first of all. Now in factorization, first of all, okay, we'll ask ourselves what are the two numbers that when you add them you have 8, and when you multiply them you have 15. That's two numbers that when you add them you have 8. Okay, when you multiply you have 15, or when you add you have minus 8, when you multiply you have plus 15. Let's work with the signs, because they really have a whole lot of effect on this. Now you will notice that first of all you have minus 3 and then you have minus 5. Now you find out that when you add minus 3 minus 5 you're going to have minus 8, and when you multiply minus 3 and minus 5, minus minus is plus, so you're going to have plus 15. So we're going to work with minus 3 and minus 5. So you have x squared minus 3x minus 5x plus 15. Okay, and that will give us x into, now we're factorizing this. Now what's common in x squared and 3x is x, so we have x into x minus 3, that's x squared divided by x is x, then minus 3x divided by x is minus 3. Okay, then what's common in minus 5 and 15? Minus 5, or even if you wanted to put a positive sign here, we could have still put a positive sign here, but let's go ahead with our minus 5. Minus 5, minus 5x divided by this will give you x. Okay, then 15 divided by minus 5 will give you minus 3. Remember, plus minus is minus. Okay, now we'll have our factorization to be x minus 5 into x minus 3. Now that's the factorization for the numerator. Now we'll still work on the denominator. Okay, working on the denominator, you have 2x squared minus 7x minus 15. Okay, now we have to find out 2 times 15 is 30. Okay, we didn't actually multiply in the first place because this figure was 1, so when you just do this one times this, you still get 1 here. Okay, that's how we didn't multiply out. Now we're going to find out what 2 numbers would you add and get 7, and when you multiply you get 30. Okay, now 3 and 10 will easily come into your mind. Okay, now 1 has to carry the negative value. Now we look at 7. Now 7 has negative value. That means the higher one will have to have negative value in order to have minus 7 here. Don't know if you understand. Now for you to have minus 7, okay, when you add 10 and 3, the 10 has to have the negative sign because it's a higher one, and then so that when you do 3 minus 10 you have minus 7. Okay, now that's how we got 3 and minus 10. So we're going to have something like this: 2x squared, let's take minus 10 first of all, minus 10x plus 3x minus 15. Now I took minus 10x first of all because I saw that minus 10x and 2 had something in common. Okay, and then 3 and 15 had something in common. I would have still interchanged it, but for us to make it easier, that's why I arranged it like this. So now what's common in 2x squared and 10x? You find out that it's 2x. Okay, now 2x squared divided by 2x will give you x, minus 10x minus 10x divided by 2x will give you 5. Okay, now plus 3 into 3x divided by 3 is going to give you x minus 5. That's minus 15 divided by 3 will give you minus 5. So our answer will be 2x, we pick this one, plus 3 into x minus 5. Now the question asked us x squared minus 8x plus 15 divided by 2x squared divided by 2x squared minus 7x minus 15. Okay, now we found out that 8x squared minus 8x plus 15 was the same as x minus 3 into x minus 5. Okay, and now we found out that 2x squared minus 7x minus 15 is the same as 2x plus 3 into x minus 5. Now we've seen that there's something in the numerator that is also in the denominator that can cancel out. So if this cancels out this, the answer becomes x minus 3 over 2x plus 3. Now that's our answer. You find out that for the factorization, we've really gone a long way from working on the linear aspect to the quadratic. Now there's something again that we should know. It's called completing the square. Completing the square formula. Okay, Now, in that completing the square formula, there are times when you have s squared minus 25, okay, and you're asked to factorize. Now you realize that in this s squared minus 25, okay, there's no x value, just like s squared minus 8x plus 15. This one has s squared value, this one has x value, and then this one has an ordinary number. Now in this kind of expression, there's no x value. Now if you're given this kind of expression, before you go further, ask yourself if the expression on the right hand side is a square of a number, that if you can get the square root. Okay, now the same way we ask ourselves, what are the two numbers that when you multiply them this you have this value. Now you find out that it's 5 and 5. Okay, now one has to carry negative because this is minus 25, so you have plus and minus. Okay, now to factorize this, you're going to have x plus 5 into x minus 5 easily. Okay, now this is called completing the square formula. Now you can also have s squared minus 36, and you'll be able to know that is plus 6 and minus 6. Then you have x plus 6 into x minus 6. You can also have I squared minus 49, for you to know that is plus 7 and minus 7. And then when you factorize, you now have x plus 7 into x minus 7. Okay, now after getting this, we'll use it to solve the other question that was given to us. We're told that 3n plus 1 all squared, okay, minus 3n minus 1 all squared is a multiple of 4 for all positive integer values of n. Just prove it. Now we've seen that this squared minus this squared given to us like this, we'll know that is a completing of the square formula thing. So now we're going to pick the first term. Let's open a bigger bracket and pick the first term, 3n plus 1. Okay, remember that when we have something like this, now we'll just say plus root of this, okay, and 3n plus 1 all squared minus 3n minus 1 all squared. Now this is more like s squared minus, now plus, this is actually, when you're solving out this, we always use this notation, x squared minus y squared equal to x plus y rather, into x minus y. Okay, for you to be able to do this one that is a bit more complex without having issues, you use x and y notations. So let's call this our x and let's call this our y. Okay, now this is our x plus, now 3n minus 1 is our y. Okay, that's this bracket. Now put another square bracket and have your x again, 3n plus 1 into minus your x, okay, now minus your y, 3n minus 1. Now you close your full bracket. Now you expand everything. Now 3n plus 1 plus 3n minus 1. You close this bracket, you open this one, 3n plus 1. Remember there's minus here, okay, so this minus will multiply out this. You have minus 3n minus minus is plus 1. Now you're going to have 3n plus 3n is 6n plus 2. Okay, rather no, this plus 1 will minus 1, so it will be 0, so this will be 6n, please. 3n plus 3n is 6n, plus 1 minus 1 is 0, so 0 goes, so it's just 6n that will be here, into 3n minus 3n is 0, so it goes, plus 1, that's 2, so we'll have 2 times 6n, 12n, and we're asked to prove that is a multiple of n. Now 4 times is a multiple of 4 rather. Now you agree with me that 4 times 3 is 12, okay? Since 12n is what we actually got from all this factorization, you will now say that it has been proved that 12n is a multiple of 4, because 4 times 3n is the same as 12n. So this is 4 and this is the multiple. So it has been proved that 12n is a multiple of 4. So that's it basically for completing the square method. Always bear in mind that it's x squared minus y squared thing. If you bear this in mind, when you have x squared minus any other thing you have here, that will always ensure that it's actually a square of a number, okay, for this completing the square method to actually work. So that's it for completing the square method and other types of factorization.